Shall we start then?
Yes, ma'am.
Yeah,
Ma'am, 2 minutes, ma'am.
okay. Okay, so now it is 11:10. I think we should start now. Okay, already. So
Yes,
last
ma'am.
day we had discussed about. I mean, we were just starting our discussion with Python, and you had. Uh, I mean, we discussed about how to create a program and then execute it, and we saw what is the purpose of IDLE, Integrated Development and Learning Environment, and how to make use of it to create new programs. So whatever programs you have already created, so it is there in a particular directory. If you have not already done, please do create a separate folder for all your works. So for day one, we had created some very, our first programs to understand what happened. So today I will have day two, the folder created under C training, C colon Python training. And under day one, you can see all our programs. They have been of, they are of type Python file. So if you see their extension, it will be PL, greet.pl, hello.pl, and welcome.pl. So we already know how to run our programs as well. So we have a run menu when you open your program in idle. You can make use of that. Or you can do one more thing. You can go to the directory where your program is present and double click on that. For example, if I want to execute this program called greet.pl, I can double click on it and it will execute. Now what happened? Greet was supposed to print hello world onto the screen, right? But we don't see any output because it already completed its work. See, it opened up, it finished its work, then it closed itself off. So it was just few fraction of seconds and then program is done and it is closed automatically and we are not able to see anything. So this is okay. This if your program has no GUI or no interface, it is supposed to just take care of some background work, then this is all well and good. You just double click on it, program executes, completes its work, and done. It's completed, done. But here we were supposed to get some output from our program, right? But we were not able to do that. There are few ways you can come around this scenario, but there is another thing. Instead of double clicking it from here, what you can do is you can go to the command prompt of Windows. I mean, if you are working on Windows, that is, you can go to the command prompt, go to the directory where your Python training. So I am changing to my changing to Python training directory. Let me see if you are not able to see the screen. I will just change the font. Is this clear? You are able to see? Are you all able to see see this screen?
Yes, ma'am.
Yeah, ma'am.
Yeah.
Ma'am.
Yeah. So what did I do? I went to the command prompt. I went to C colon Python training. That is my directory. Python training / day one. Okay, that's my directory, day one. And if I give dir, I can see all my programs here, greet.py, hello.py. I can execute them from here as well. I can just say Python greet.py. So I see this output. So suppose you have written a program, a small program which reorganizes files on your desktop or some specific directory based on the extension of the files. And suppose your friend noticed it and he said, it's a good program. I also can make use of it. I want it. So he takes it from you. He copies that into his computer. And how does he execute? He doesn't need to have Python or idle. I mean, he doesn't need to open it in idle and then run from there. He just have to go to the directory where he had copied that program and then say Python space the name of your program. That's it, and it will execute. So what is this Python? That is the interpreter. That is a Python interpreter. So in Windows, it is installed as python.exe, which is a Python interpreter. So we are calling the Python interpreter and passing the name of our program directly to it. Okay. So the interpreter opens the file, parses through it, compiles the file into an intermediate binary. intermediate opcode file, binary code file, and then calls the interpreter. Then actually the compilation and the interpretation happens one after the other, but without our intervention. We don't have to do anything on it. We just have to give the name of the file to python.exe, and it will internally call the compiler, compile it into an intermediate binary, and then execute it with the help of the interpreter. Okay. And if you have learned Java before, if you know how Java works, then it is very much similar. You know that in Java, the only difference is in Java, when you have completed writing your program, you run Java C to get it compiled into a class file, .class file. So this intermediate binary code is available in the .class file, and this class file you will execute. That is what happens in the case of Java. It is the same thing happening here. Only thing is that we don't have to call Java C or any Python compiler here, because this compiler is invoked internally by the interpreter itself. So this compilation step, you don't do anything manually. It internally does the compilation and then execute it directly. Okay. So that is why we call Python as an interpreted language. Actually, there is a partial compilation which happens, but only the difference is that it is not compiling into a exe. So you cannot directly execute, convert it into an exe and then do it. You can, but it requires some other tools. We don't require to do any of those sort. You just have to say Python greet.py. And where is this Python? Where is this python.exe itself sitting? It is in the installation folder. Wherever your Python is installed in your system, it is there in the Python. So as long as python.exe is accessible from the path, you can call Python from any directory. It doesn't matter. For example, I close this command prompt. I start it again. I am starting the command prompt again. So now I am in C: user separate solutions. I am not under C drive where my program is. It doesn't matter. I can just say Python C: Python training. That's my directory name, /day1. That is my subdirectory. greet.py. Okay. If I want to execute the welcome program, I'll say welcome.py. Enter your name. See, my program is executing. So your Python programs can be copied to any appropriate location, and you can execute it anytime by calling Python direct. Okay. So you don't have to have idle or any other Python development environment installed in order to run your program. You can run it directly from the command prompt. Is that clear?
Ma'am.
Yeah, anyone has doubt? Is that clear?
Yeah, ma'am.
Yeah. I hope it is for everyone. Okay. So so that is one way of executing your programs. And this python.exe, if you want to find out which version of Python is being invoked, for example, if you have noticed earlier, in my system I have Python 3.8 as well as Python 3.102 separate versions available. So if I want to find out which is the version of Python which is currently executing, you can call it by this option, Python _version. So you see it is Python 3.10 which is installed, sorry, which is being invoked. Okay. So you can try this in your systems also quickly. Invoking your Python program from command prompt. Shall we continue?
Yes, ma'am.
Yeah. So let us get back into the language itself. Let us discuss more about it. Okay. So now, um, okay, why do we write programs in the first place? Programs, software, applications. Why do we create them? We create them to work with some kind of data, isn't it? For example, if um, if you take Microsoft Word, it is to create and edit documents which are mostly text data, but it might contain other things like graphs, pictures, so many other things as well. If you take the case of Microsoft Excel, it is to work with numeric data mostly, but it also can contain these kinds of things additional to, in addition to text and stuff like that. You take the case of a calculator, it works with numbers and specific operations on that. If you take a web browser, then it works with, data streamed from specific locations. And if you take with a movie, what do you say, some music application, then it works with streamed music. You have some more the other kind of data to work with in a specific manner, and that is why you create programs, customized or not. You work with them in order to work with some kind of data. So in any programming language, dealing with data, how to work around data is a fundamental thing what you learn. Any programming language you take. In Python also it is the same thing. So we are going to work with, you know, we are going to understand how to take care of data. I mean, how to work with data in Python programming. So data comes in many formats, isn't it? It can be number, it's a string, it can be a floating point number, it can be a complex number, it can be a pixel coordinate, which is again in numbers. It can be some true or false value. It can be, anything, any coordinates, colors. It can be in various formats. Data may come in various formats. Any kind of information you want to store, we have to know what appropriate way in which we can store this particular data, what facility this programming language provides us with. So if you have already learned C, C++, etc., we know that we have int, float, char, so many data types which we have to understand, so that we can define that this data is going to be int, this data is going to be float, this data is going to be long, this is going to be a car, this is going to be an array. So we should know what kind of data structure that data will fit into. So in Python also we have different data types to work with. Okay. So here Python also allows you to work with numbers, strings, true or false data, collections of data like arrays and dictionaries, etc., like that. So all these data structures we will discuss one after the other. Okay. And before that, we will have a quick look at variables. And everybody has an idea about variables. You being computer science background students, I don't have to explain to you in detail what a variable is. Somebody tell me what is a variable? Someone? What is a variable? Ganesh? I'll call names from now onwards. Madhav? What is a variable? What happened to Ganesh and Madhav? Are you able to hear me?
Storing data values
Where?
in data types into float, character, double.
Yeah, I mean, but where is this variable located? I mean, where is this variable storing values? Memory, right?
Yeah.
Yeah.
Yes, ma'am.
Yeah, see, variable is nothing but, see, the data when a program runs, whatever data it is dealing with, whatever data it stores and manages, everything is stored in the memory, isn't it? And when the program closes, the memory also will be wiped out and all the data will be lost. So if you want to save this data, we will save them in files, etc. Okay. So this data, when a program runs, whatever data it uses, it is all in memory. And where in memory? Memory is a huge location. It can be in megabytes, gigabytes, tetrabytes. There will be lot of space, a lot of data, and your data is going to be stored in some location somewhere. So if the program wants that data again, it will have to know which location where did it store that data. So it has to know the address of the memory where that particular data is located, and so that it can retrieve it from there. Now dealing with memory addresses is a cumbersome process. It is almost next to impossible because it is numeric. I mean, hexadecimal addresses which we have to deal with if you have to directly refer to a memory location. It's not that it is not possible, but that is not what we want to do and especially when you have huge amounts of data to work with. So variables make this easy for us. Variable is just a name given to a memory location. So you can say it maps the name to a memory address. So that when I say give me the value of variable name, it knows which address the name is referring to, and it goes to that address and picks up and gives it. So as for us programmers, dealing with memory makes it is made easier with the help of variables. Variables help us store data and retrieve them in a very easy manner. Whatever may be that data, it can be a number, it can be somebody's name, it can be an address, it can be some pixel coordinate, whatever it is, whatever data it is. So variables are integral to any program. Every program works with at least one variable. So let me open our yesterday's program called welcome. Here we have used one variable, isn't it? Which variable is that? User. Why was it required? Because when the user enters some value, we need a variable to store this in memory. So that variable is user here, this one. So after storing it, we are again retrieving that value and using it here by using that variable's name. So these two lines, they are very simple, isn't it? What is it? We are printing a message onto a screen, enter your name, and whenever and waiting for that input from the user. Once the user enters this value, it is stored in the variable user. And later we go ahead and then print welcome followed by the value of the user. That's very, very simple, straightforward. But did we say anything like the user is going to be a numeric variable, or it is a character type variable, or it is a boolean? Did we say anything like that? If you notice, we have not done anything like that. So what happens? How does Python know that it is going to be string? Thing is that Python actually doesn't know. So instead of a name, if I enter a number, it will not complain. It will just simply accept that value and say welcome 23. So that is one thing about Python you have to keep in mind, that in Python, when you use variables, you don't define the type of the variable. You don't say this variable is int, this variable is float, this variable is char. You don't have to say that. You just have to give a name to the variable, that's all. Based on the value stored in the variable, Python will treat it as an integer or a character or a float or whatever. Okay. So the value determines the type of the variable in Python. So what is the type of this variable now? You can easily guess that it can be a string or an integer or whatever. So we will see more about using variables shortly. Before getting into that, let us decide how to name variables. Variable naming rules are also just like any other programming language which you have already learned. That is the common rules what we follow. Variable names should not contain spaces or special characters. Variable names should always start with an alphabet or an underscore. It can contain numbers, but it cannot start, variable name cannot start with a number. For example, I can say user1. That is a valid variable name, but I cannot say one user, or I cannot say one underscore user. Those are wrong. These two are wrong, the next two. I can say underscore user because it starts with a valid character underscore. That is okay. So the first one and last one both are valid names. The second and third are invalid names. If I want to say user space 1, that's also wrong, isn't it? Because it contains a space or some special characters. If it contains, that is also not allowed. So variable naming rules are just like any other programming language. Now we know how Python treats variables. As we start using variables, these things will become more clear to you. Let us start working with data in Python. Make use of some data. Let us start with the easiest one, numbers. Okay, we will start with numeric data. So let me open a new file. I'll close the older one, welcome. I don't require it now. I will work with the new one. Okay, I'll say working with numbers. Okay, so how do we create a variable? So before going into the program, I will go back to idle itself and let us try working in idle for some time. I'll just create some variables, work around them with in idle itself. We'll not write a program straight away. So yesterday we used a variable called user. User is equal to, I say, or let us start with numbers themselves. I'll say a variable called num is equal to 23. So what does this statement do? It is creating a variable num with a value, initial value of 23. So what is this value 23? Is it in quotes? No, it looks like a normal integer value itself, isn't it? So what does Python do? Python understands that you want to store a numeric value in a variable called num. So it creates a numeric variable called num, and looking at the value itself, Python understands that it is a normal integer. So it makes the type of this variable as integer. Suppose I have another variable called num1. Now this time I say 23.5. Now this is again Python understands that I want to store a variable called I want to store a value 23.5 in a variable called num1, and looking at the value and based on the value it understands that it is a float value, so it creates it as a float. So how do we know? It's easy to find out. There is a built-in function called type in Python. We can make use of that. I can say type of num. See this? Int. So if I say type of num1, see it says float. So how did it know that it has to be a float, not an integer? Because the value is a floating point value, isn't it? It contains a decimal fraction part. Decimal, it's a decimal number. Fine. So in Python let me say num is equal to minus 23. Now it is a negative number. So if I try to type of num, you can say still it is integer, it's a negative number. So you can have numbers, normal regular numbers like positive or negative numbers, decimal numbers, numbers with what you say scientific format, like for example I say num1 is equal to 23.5 e raised to 10, sorry, e10, meaning 23.5 into 10 raised to 10, that is what it means. Okay, so I say type of num1, see it is still class 4. But what will happen if I print num1? I say print num1. See, this is the value I get. 23.5 into 10 raised to 10. Look at the value, which is it is printing. So what is this common to all these? All these are numeric type values. So what all different formats I can use? I can use normal decimal numbers, uh, negative numbers and positive numbers, and exponential format I can use. I can create them in binary, octal or hex format as well. For example, I want to create a, store a binary value into it. But remember, this binary value, when it is stored, it will be converted into equivalent decimal and then stored. So for example, if I want to store a binary number, it has to mandatorily start with 0B, 0B101. So this is 5, right? So when I say print num, it will print the equivalent numerical value. Got it? So what is your guess? How do I store the octal value? Octal value will be when I start any numeric value with a 0 and O. 0B means binary. Num is equal to, I say 0 O. See, the octal value 123 converted into the equivalent decimal number. So if I want to store a hexa value, then I can say 0x yeah, I have a problem. You know why that problem comes? Spelling mistake. See, these are the various. So what are we looking at? We are looking at various ways in which numbers can be used. I mean, initialized in Python. So various formats, creation of numeric variables, and various ways in which numbers can be represented in Python. So whatever format we use internally, they are all going to be stored as double precision decimal values. Okay, decimal numbers. Try all these. Just quickly give a try to all these. So we have been creating variables. We created two variables, num and num1, and initialized them with various formats of numbers. Tell me if anything is unclear or if I am going fast.
Completed, madam. Still typing.
Pardon?
Still typing, madam. Not completed.
Yeah, it is okay. But yeah, I'm just asking whether you are following.
Yes, ma'am. Following.
Yeah. This E here in this example, this E here can be small letter E also. Okay, E, small letter E or upper class E.
Close, madam.
Pardon? See, this is the advantage of using idle. It is a quick learning platform. So we don't have to spend time in creating a file, putting all the commands, saving it in and executing in executing it again to see the output, then go back and change, give additional commands, execute it again. So you don't need that cycle. You can quickly type your commands here, syntaxes here, and see how they work. And later you can put them into your program. So idle is a quick way to learn syntaxes. So this is 0, O. O standing for octal. Okay, so I guess it, I hope it is done. So in order to create any variable and store a value into it, you don't have to define a type for your variable. You just have to say variable name equal to whatever value you want to give. So internally, based on the value, Python will determine whether it should be integer or float or character or whatever it is. So we know that Python is object oriented, isn't it? So even if we are not creating any class or whatever, you can clearly see that from here, that this float is nothing but a type specified by a class called float in Python. That's why when I say type of Python, give me the type of Python, num1, it is instead of simply saying float, it is saying class float. So far we have seen three functions in Python, three built-in functions of Python. Which are they? Which are the three built-in functions of Python, which we have already seen? Anyone? Lakshmi Priya? Yeah, tell me, Lakshmi. Which are the three built-in functions which you have already seen?
Can you repeat the question, ma'am?
I asked, which are the three built-in functions of Python which we have already used? The first one is
Int float, ma'am.
no. That is a data type. That is a type of the data. I am asking about the built-in functions of Python. So far, in the last class and today, we have used three built-in functions. The first function we used in our first program itself. Which one was that?
Print, ma'am.
Print. Yeah. Next one.
Type.
Type. This one. Type this function. The another one.
Yes, ma'am.
Input.
Input. Okay, ma'am.
Yeah. So we will keep on doing this, and we will on the way we will keep on lot of built-in functions and keywords and other things in Python. So today we are discussing about data types, and the first data type what we are discussing is number. And what are the different formats of number, what or different types of numbers what Python supports? Integers and floats. Okay. The data can be given in different format like normal decimal format, binary format, octal format, or hexadecimal format. Whatever format you give, it internally converts that into a normal decimal number. So 0B101 means I am storing a binary number 101, which is equivalent of the decimal number 5. So you can see that even though I give it while initializing, when I am printing, I am getting. Okay, so let us continue now. Continue into the next portion. So we know how to create a numeric variable, number variable, and then yeah, before we move further, we saw integers and floats. There is one more type of number what Python allows you to store and manage. Those are complex numbers. We all have learned about the complex numbers. So complex numbers also can be stored in Python. For example, suppose I have a variable called a, okay, and I want to store a complex number in it. This is how you can store. Complex numbers are of the format real number plus complex part. So you have 1 plus 6j, that is the number what I have given. So this is the format which you will use for your real part and imaginary part specified in this manner. If this kind of a number is what I am storing, then what is the type of a? Is it integer or is it float? It is neither integer nor float. It will be of type complex. For example, I say type of a, type of the variable a I want to see. I can see that it is of type complex. So if somebody asks you what are the three basic numeric types what Python allows you to store, you should say integers, floats, and complex numbers. Okay. Okay, let us move further. What can you do with these numbers? In Python, what all things are possible? What all operations are possible using numbers? Whenever you want to perform something on this data, you should make use of operators in Python. So the numeric operators are what we already know about, like your plus, minus, division, multiplication. Okay. So plus, minus, slash, star represent the normal basic operations. Double star is for exponent. Okay. Double slash is for floor division. Okay. So these are some of the operators related to numeric arithmetic operations in Python. For example, I have two variables. A is equal to 10. Now I have b, another variable b is equal to, suppose the value is 25. If I want to add them, it is simply a plus b. If I want to subtract, it is a minus b. Divide, floor division. Now I'll get, I'll say b divided by a is 2.5. b, floor division a is round off to the lowest lower number. So I will get 2. Now a is 10. So if I say a double star 5, it is 10 raised to 5. So b is 25. If I say b double star 3, it means b raised to 3. 25 raised to 3 in this case. Okay. So these are the simple arithmetic operations. Another one what you have is modulo operator. So if I say b divided by a, it is 2.5. If I say b percentage a, it is modulo, remainder. Remainder is 5. So these are the basic arithmetic operators available for Python. Just quickly try them out. Whatever variable, you can create your own variable. You can put your own values. You can perform any operations what you want. Complex operations, if you want to make use of parentheses, that is also possible. For example, I want to say a plus b divided by 5. A plus b is 35. 35 divided by 5 is 7. Just experiment with some basic numbers. Is it done?
Yeah, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. Okay. So let us now, okay, what are the other operations you would like to perform on numbers? Arithmetic, other than that? Comparisons?
Trigonometry, ma'am.
For trigonometry, you have built-in functions available. Okay. Uh, it's not built-in function. It's not a built-in function of Python. How to do that? We will shortly see. Okay, I will tell you. But before that, what about comparisons? I want to compare two numbers. Okay. For example, who got the highest mark in the class? Or uh, is this age? I mean, is he eligible to what? His age is so much. I want to find out whether he is eligible to what. So we'll compare against 18, isn't it? Is it greater than 18? So you would like to compare against each other. Numbers can be compared against each other also. So comparison operators also are available in Python. So simple greater than, it is for your greater than, then less than, greater than or equal to, less than or equal to. And whether they are equal, if you want, you can find out using double equal to. Remember, single equal to is for assignment, double equal to is for comparison. For example, if I say a equal to 10, I am assigning the value. If I say a double equal to 10, I am testing whether a is equal to 10. So now it returns true. Yes, it is true. So this is your comparison operator. Is a greater than b? False. Is b greater than a? So it should be true. Is it a less than b? Yes, it is true. Less than or equal to b? True, it is less. Is a less than 20? Yes, it is 10. It is still less than 20. Okay. Is a not equal to 10? What it will say? It will say false because it is actually equal to 10. So it will say false. It is equal to 10. So that is your normal comparison operator. Whenever comparison operators come into picture, you have logical operators as well. isn't it? And or. For example, I want to find out is A a greater, I mean, is a value between 10 and 20. I want to find out if A is between 10 and 20. So how do I find that out? I can say if A greater than or equal to 10 and A less than or equal to 20. I need to compare within two values. Suppose A is equal to some new value like 16. A's current value is 16 and I want to find out if A is greater than or equal to 10 and less than or equal to 20. So two conditions I am combining together using an and. Am I clear? Is there any network disturbances?
No, ma'am.
Okay. So this is how you use and, okay, A and D in literal format. If you want to use or, then it is simple or. For example, if A is greater than 10 or B is less than 20. True. Why? Let me see what is the value of B. B is 20. B is not less than 20. This part is false. This condition is false. But this condition is true. Isn't it? A is greater than 10. Let me rewrite A greater than 30 and B greater than 20. Now it is false because both the conditions are false. A is not greater than 30 and B is not less than 20. So both the conditions being false, it gives false. So these are the logical operators of Python. And then or. And you have not as well. Okay. So we saw how to create numerical variables, what different formats I can use. And then we also saw how to make use of them to perform simple arithmetic operations. And now we have also seen how to compare them using comparison operators and logic with the help of logical operators as well in Python. Okay. Let us make use of this knowledge to write small programs. Okay, we have been asked to accept two numbers and find the biggest number. You know how to accept numbers, isn't it? And you know how to accept values and you know how to print the bigger number. Or let us do one thing. Okay, I don't want to print the bigger number straight away. I'll just do one thing and you know print their product. That's a very simple one. Very simple. Now let me write this program. I mean, it is very simple. Everybody can write it. I am just going to show you something in this. How to accept two numbers. We have already discussed how to accept a value. Just tell me somebody How to proceed? What to write now? I want to accept the first number. Which function to use to accept a value? Sunanda? Which function? We already discussed. Pardon?
Number.
Yeah, see, that is a number which you are supposed to accept. But
Input, ma'am.
yeah, in order to accept a number or a value, any kind of value, whether it is a number or name or whatever, if I want to accept the value into my program, which function will help me do that?
Input, ma'am.
Yeah, input. Remember this program?
Yeah, ma'am.
Yeah. So what does the first line do? It accepts a value and waits for the user and accepts a value. Let us try the same thing here in our program also. We are asked to write a program to accept two numbers. Let me accept the first number. Okay. So I will make use of the built-in function of Python. I'll say input, enter number 1, or I'll say enter first number. Why do I need quotes inside? Because it is a string value. It's a literal string, isn't it? So I'll have to put the entire thing in quotes. So I'll say input, enter first number. Okay. Let me not do anything further. Let me not write anything further. Let me just execute only this much. I'll say file save. This time I will go into the date to folder and I will say product. Whatever name you want to give for your program, you can give. The name what I am giving is product. Let us see what happens when I run this program. Enter first number and I enter the first number 100%. Anything happened? Nothing happened because that is the only thing which I asked. Accept a number, that's all. What to do with the number we have not yet discussed. So first thing what we require is a variable to store the value which we just now entered. So since we require two numbers, I can have two variables. The first one I will call as num1. You can call it by any name, A, B, X, Y, anything as appropriate. Similarly, I now require the second number also to be accepted. So I'll say num2, my next variable. Okay, num1 and num2. Let us just print them out. Let's see whether they are printing properly. Num1 and num2, num1 comma num2. I'm just printing num1 and num2. Let's see run module. Enter first number, I enter some number, 12 I enter. Second number I enter 56. So see, it is printing properly, isn't it? 12 and 56. That's it. It's printing properly. I understood. That is fine. So our values are being accepted fine. Now tell me what is the third line which I should write. What is that? The first part of the program is done, accepting new numbers. Now what we have to do is print the product. That is multiply them together. Okay. Yeah. Now somebody tell me how to complete this. Hemant, tell me what should I write next. We have two values at hand. What are we supposed to do next? Hemant, are you there?
Print M1 asterisk M2, ma'am.
Print num1.
M1 asterisk M2.
Yeah, asterisk num2. That's it. The product. I'll say run module. I'll enter the same numbers 12 and then 56. Yeah. Now what is the problem? That was very straightforward, isn't it? But what I am getting is an error.
Number spelling, ma'am.
Is it? The variable name is num1 and num2, and here I gave proper num1 and num2 only. It is correct, right? So let us look at the error message very clearly. Let us see what does this message tell us. What is this message? It says type error. The data type is incorrect. That is what it is trying to say. It says cannot multiply sequence by non-integer of type str. What is it? The value what we entered was normal integers only, but it is saying that it is str, that is string. Okay, it's a non-int. It is not an integer, it says. So that is our problem. Whenever we accept a value from the user, if he is entering a number, the program still thinks that it is string. It's not taking it as a number called 12. It is thinking as it is a sequence of two characters, 1 and 2. Just 1 and 2, two characters. That is what it thinks. So that is not appropriate, isn't it? What we entered is a number. So what we just need to do to make this program work is convert the string data into number data. What we call as typecasting. Okay. So what is typecasting? What typecasting we are going to do now? We are going to typecast the string data into integer data. For that, you just have to say, you can do like this. Int of num1, integer of num1 into integer of num2. So convert num1 into integer and num2 also into integer and then multiply. Let's see if it works. Let me enter the same two values. I'll enter 12 and 56. See, now I get the proper value. So remember, whenever you are accepting numeric values from the user, you should convert that into integer or float as appropriate. Always it is not integer. Now what we are entering as integer, that is why into was used. Otherwise float or even complex can be used for the purpose. So normally this conversion is not done at this stage. It is done when we are accepting itself, at the type of accepting itself. So this is how you usually write it. Int of the value accepted by int. Okay, this is how you write. Int of input of this value. So again, the same thing. See, I get. So the program is very simple, very simple. It has only 3 lines. But, 2 lines to accept 2 individual values and 3rd line to calculate the product. That's it. But in addition, you had to do a data conversion, type conversion into integer. So try this program out and tell me if anyone has not understood that. You don't have to worry about whether other people have understood or whatever. You can just ask the doubt. So just quickly try this program. So this is known as chaining of functions. Functions are chained one after the other. So input is inside the int function, meaning first input will execute, then the result of that one will be used by int to complete its work. Instead of int, if I use float, suppose instead of int I am using float here, then I run the program, then I enter two integer values same as before. See, you get the result in floating point value because they were converted both into floats. So it is up to you whether the user is going to enter a numerical value or he is supposed to enter an integer value or float value and accordingly do the conversion. Has everyone completed this?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. Anyone who has not? Okay. Now you asked me about trigonometric functions. Now, trigonometric functions, I mean sine, cos, tan, all of them are available easily in Python, but not as built-in functions in Python like print or input. They are built-in functions. These trigonometric functions are also available, but they are available with the help of what is called as a module. Okay, a module is nothing but a library where some functions, some code are grouped together and saved so that anyone requires, they can make use of that module. So for normal, working, not everybody needs to use trigonometry in their everyday programming or work. If anyone needs to use them, then they can make use of them by making use of that specific module. Which module is that? This module has a name called math. It is called as math. If you want to make use of that module in your Perl program, the first thing what you need to do is you need to import that. Okay, so you need to know which module I can use for this purpose. And if you know the name of the module, first thing what you need to do is import that module. So the statement is import followed by the name of the module. In this case, our module is called math. So what is this math module? If I want to know more about this math module and to understand what is available in this math module, you have certain things, you can do certain things. Like for example, you can take a help of this math module. Okay, you can print a help regarding this math module. So it contains 281 lines. So it is squeeze text. If you double click on this button, then it will open up. Help on built-in module math. Description. This module provides access to mathematical functions defined by the C standard. What are these? A cos h, s in h, a tan, ceiling, cos, so many. You can see exponent, factorial, floor, so many. So many arithmetic functions, sorry, mathematical functions are available within this math module. Okay, it's finite, is man, sqrt, log 10, mod, okay, so many of them. And it also has some called data. See, these are nothing but constants defined in this variable, like our pi. Okay, the constant pi is defined here. Suppose I want to calculate the circumference of a circle with a radius of 6 centimeter. I can say math dot pi multiplied by 2 into 6. So I get this circumference. So I didn't have to type the value of pi, isn't it? The pi value is already available from the math module. So remember, this module, in order to use it like this, before using it, it has to be imported. I have already imported, that is why I am able to say math.py into whatever. Okay. So if I want to find out, okay. So if I want to find out the sign value of something, yeah, I can say like this. So these functions which are available, for example, truncate and ULP. So if I want to make use of that, since they are all coming from the module, you have to precede that function name with the module name. So I cannot just directly say pi. If I say just pi, it will complain. It will say I don't recognize this pi. It's not defined. It will say. Same way here also. If I just say sine, it will complain. It says it doesn't understand that. So you will have to make use of the module name, then dot and that value. Okay. So in one more thing you can notice in idle, the moment I put a module name and then a dot, it takes a few seconds and then I can see all these functions and variables I can access from it. See? Okay, sqrt. SQRT of 256. 16. Got it? So several modules like this we will be discussing and using on the way. When we keep on discussing things, we will keep on encountering many modules on its way. But remember, Python's module library is very vast. It is, thousands and thousands of modules are available for different purposes. These modules are some which are available as part of the default installation. They are already there. Some modules are not available, but they are available for download from the net. How to download them, where to search for them, those things we will be discussing at a later point. Okay, so this is one module. There is another module, so you can experiment. You can experiment with all these functions in various ways. So this help, what we just now saw, gives us an idea in this manner. If I want a little more detailed one about each of the functions, that also you can do. I can say help of math.sign. If I want to find some additional help regarding math.sign, I can say help math.sign. See, return the sign of x measured in radians. Okay. So what can you do? Okay, that is one thing. So you can say import followed by the module name. Then in order to find help, you can say help of that module name. If in order to find the help on specific function, you can say help that particular function, module dot that function. Let us take another example module called random. As the name suggests, it is all about random numbers, random choices, random sequence values, etc. like that. So this module name is called random. If I want to download, if I want to make use of it, the first thing is import random. So let us see what this random module is about. I can say help random. 658 lines. Help on module random. Name random variable generators. So see, it allows us to work on bytes, integers. Pardon?
Ma'am, excuse me, ma'am.
Yeah.
Ma'am, we lost electricity, ma'am. Can you please wait 5 minutes, ma'am?
Okay.
Okay, thank you, ma'am. Um,
Yes, is it done?
Ma'am, you can start, ma'am. Ma'am,
Okay,
start, sir.
so yeah. So we are now looking at the random module, and it works with different types of data like bytes, integer, sequences. We will see more about byte sequences later. Okay, and it's a big module. It has classes, further classes internally, class random. Okay, there are a lot of functions. See, it has a section on functions. So you can see that it is huge. A lot of things may not be even used by us even once. Okay. Now, if I want to find out what kind of functions or what all functions I can use from this module, each of these module has lot of functions. What are the names of these functions? Which all functions I can use from them? Picking up from this help text which runs into many pages is difficult. You cannot keep on reading through all of them at once, isn't it? You can, I mean, if you have a specific need of working entirely specifically on random modules, you should have a good look at it, look at the help documents, everything. But if you want to quickly get a list of functions what is available, then instead of the help, okay, you can do uh, you can make use of another function called dir. Okay, you can give the name of the module there. I can say dir of random. See, these are the functions which are available from that module to be used. So this is much more shorter and concise output, isn't it? But this also looks very big. It has again too many. Yes, some modules are very big. They have too many functions available. But remember, whenever we get a directory listing of any module, just ignore whatever starts with an underscore. Okay, if any name starts with an underscore, just ignore it. When we discuss about object orientation later, when we are going to study object orientation, then we will see what they are, and even if you have to use them, how to use them, etc., like that. So for you, for simplicity's sake, just look at only the function names without an underscore in the beginning. Okay, now you have a function like seed. I want to know what this seed function will do. For that, you can make use of the help function again. I can say help random dot seed. Right? Initialize internal state from a seed. Okay, the only supported seed types are none, int, float, str. So you can see that initialize internal state from a seed. So it allows us to initialize a random state with a seed value, with an initial value. Otherwise, it will start from the value 0. There is something called choice. I want to find out what is that choice about. So I can say help, give me some help on this choice function of the random module. It says choose a random element from a non-empty sequence. Sequence is nothing but a collection of values. From a collection of values, help me choose some random element. That is what it means. So what is it? We discussed a few things in the last few minutes, I mean 10-15 minutes. We discussed about modules. What is a module? A module is a collection of Python code, reusable Python code. You can consider them as reusable Python functions. They contain other things other than functions like classes, class definitions, constants, etc. But you can, for the basic thing, you can consider library is nothing but a collection of functions. What is the advantage of a library? It allows us to reuse code without having to write anything from scratch. I mean, many things from scratch. For example, if I want trigonometry to be used in my programs, I know that I don't have to worry about how to implement it because these things are available in the form of functions in a module called math. So what I need to do is, first thing, I need to import the math module. I'll say import math. Then any required function I can call from this math module using the syntax math dot the function name. Okay. For example, here in random, we have already imported random. Only after importing the module, I can get the help regarding the module. So even if I want to see the help text, I have to first import the module. Okay, let us do one thing. I will print a random number. I'll say random dot random. See, this is a random number. I will call the function once again. This time I will get another random number. See, still another random number. If I want a random integer number within the range of 1 to 10, I can say print random dot rand ind. There is another function in random called rand ind, which accepts a range of values. I mean, a range and any value, random value within the range it will give me. For example, any random value between 10 and 20 if I want. So I will say 10, 20. See, it gives me one random value 11 now. Now another random value is giving me 20. Now this time it is giving me 13. Once again it is giving me 13. Now it is giving me 14. See, each call gives me a different value at a time. Okay. So whenever you need to make use of random elements, either to choose from a selection of values or to create a random password, for a lot of things. Um, you can make use of this random values. So any purpose of random values, you can immediately remember, okay, I have a module called random, let me make use of it. So first you import it, find out if an appropriate function is available, then get help on that function to see how to make use of it, and then use it in your program. Okay. More about modules, we will again discuss later in detail about modules at a later stage. This is the basic, because in our basic work also we might require some modules here and there. So you should know how to import modules, how to call functions from it. So that is what we just now discussed. Okay. So that is it for today. So today we have discussed about variables, how to initialize, create and initialize integer variables, what all different types of integer variables are supported, what are the different operators available to work on integer variables, and basic idea about modules. These are the things what we have discussed today. Okay. So on Monday, we will discuss further about all these things, and how to work with strings we will see in our next day's class. If anything is unclear, any doubt you want to clarify, you can message me in this number. This is my number, 9442363343. You can give me a message. Okay. So please clarify all your doubts if at all anybody has got. Um, um, at appropriate times because if we proceed much further, then you will lose track. So that is for today. We will see on Monday.
Okay, ma'am.
Thank you, ma'am.
Thank you.
Yeah, bye.